We are officially at the top of the hour, so I think we're going to get started. Good morning, good evening, good afternoon, everyone. My name is Frederick Winsness, and I am with the NetHope Solutions Center, and delighted to welcome you to another one of our webinars. Today we have a webinar on an artificial intelligence primer, and it's going to be interesting to get the basics for artificial intelligence and its connection to the humanitarian sector. But before we get started, let me go over a little bit of housekeeping rules. We want to make this as interactive as possible, so please open the chat window. That is the third icon from the right at the bottom of your screen. And there you can post your questions, and we will do question and answers towards the end of the hour today. And we are recording this session today, and please look for a follow-up email with links to where you can find the recording and the slides and all the collaterals from the session this morning or afternoon or evening, wherever you might be. We're also going to present you with a survey towards the end of the hour today. So if you have a couple of minutes to answer those questions, that would be very helpful for us to improve this webinar series over time. So with that, I'm going to turn it over to our host today, Leila Toplik. She is the lead for emerging technologies, the working group at NetHope. So over to you, Leila.
And good morning. Thank you so much, Frederick. Good morning, good afternoon, and welcome. And it's great to see such a good turnout, especially during the summer holiday season. So it only, I think, speaks to the growing interest in our sector to understand the value as well as implications of AI on our work and the communities we support. I'd like to welcome our presenters. Aubrey Anthony is the Strategy and Research Lead at the Center for Digital Development at USAID. And Cyril Glockner is a Principal Program Manager for Business AI at Microsoft. And both Aubrey and Cyril have presented at NetHope's AI for Good workshops, most recently at the AI for Good Summit at the UN in Geneva. So if we can click to my deck quickly, I will take you through a quick overview. Let me just, Frederick, here we go. Fantastic. So before we dive into the content, I wanted to provide you with some context on how this webinar fits into the work that we're doing at NetHope. Since we established the Emerging Technologies Initiative earlier this year, we've been focusing on three areas or three needs that were identified by NetHope members and partners at NetHope Summit last year, so 2018. First, capacity building through workshops and sharing of the practical implementations and lessons learned. Second, frameworks, guides, toolkits that can help us make the use of AI more efficient and more effective. And then lastly, we've focused on facilitating the support needed for our sector to get started with exploring using AI in field programs, as well as to enhance our internal processes. And this webinar is focusing on the first pillar, capacity building. And today's webinar is meant to prepare those of you who are coming to NetHope Summit in October for the AI for Good sessions, and obviously more broadly inform all of us about the artificial intelligence and machine learning. And on this slide, you see an overview of what we have planned for the next couple of months. We'll begin this conversation today and obviously cover a lot more in the upcoming sessions. Following this webinar on September 19th, we'll start going into some of the early practical implementations in the nonprofit sector. In that session, we'll learn more about AI in the conservation context. We have two implementations that will be featured, one by Carnegie Mellon University in collaboration with a number of partners, including NetHope members, and another one focused on mapping ocean wealth by one of NetHope members, that is the Nature Conservancy. And at the summit, we have several sessions planned as part of the overall emerging technologies track. On October 21st, as part of the AI working group, we'll have a working session focused on ethical AI. So we're not going to go deep into ethical AI, ethical considerations today. We have a whole session, about 90 minutes, planned with the intent to inform what might be a practical guide for ethical AI for practitioners. So more on that soon. And then following that session, we have time dedicated to learning about AI and machine learning tools and services that are ready to be used in nonprofit work. So expect to see some demos of off-the-shelf tools and services during that session. We'll give you a preview today, but a lot more to come at the summit. And then just a couple of days later, on October 23rd, we'll have two sessions. First, we want to continue learning from the practical implementation. So this time we'll hear from two NetHope members and their partners, so from the Carter Center and from Plan International. That session will be followed by a hands-on session where nonprofits will come with specific problem statements, whether they're related to field programs or internal operations that they're really looking to solve, and with the help from technical subject matter experts, they'll have the opportunity to evaluate if any of the AI capabilities could contribute to the solution. We've done this at a couple of workshops already this year, and it proved to be an effective way to move from theory into something that is highly practical and relevant to the work that we do in our sector. So, but for those of you who won't be joining us at the summit, we'll package up summit content and the key takeaways and share them via webinars and also on the NetHope Solutions Center. So briefly, in terms of some of the resources that are currently available, I want to just highlight two resources that were developed over the past few months in collaboration with NetHope members and the number of partners like USAID, MIT, Microsoft, IBM, and others. First is a framework that we'll spend more time on as we dive into the practical implementations, but we want to make sure that's available to you and visible to you today. It's a framework that was designed to help nonprofit sector know what questions to ask when evaluating and incorporating AI into our work. This framework includes questions for each stage, from defining the opportunity, even asking the question, do you really need AI for this specific, to address this specific problem, evaluating data and bias, resourcing the solution, all the way to implementing the solution, maintaining and extending the solution. So do take a look. There's also a repository of tools and services and training resources, and this will continue to evolve with the input from more partners. So take a look and let us know if you have any input or questions. Now, with that, let's talk about what we're going to cover today and some context on this. The content for this AI Primer webinar is based on the direct input on the ideas, suggestions, feedback from many of the NetHope members, our global NGOs. In fact, this specific deck is the third iteration of the AI Primer since last October. And a special thanks to Abra and her team at USAID, as well as Cyril, for continuing to collaborate with us to make this introduction to AI truly relevant for our sector. Abra, Cyril, and I have designed this content for the webinar to answer 4 questions that many of our NetHope members, like Plan International, PATH, the Nature Conservancy, Catholic Relief Services, have recommended that we start with. First question is around what is artificial intelligence, what is machine learning, what is big data? So we'll spend some time on that. Then we'll talk about what are some of the types of machine learning. And then we'll go into the AI capabilities. And this is where we'll also talk about how those capabilities are being applied today in our sector. And then what's more, you'll see a demo of one of those capabilities. While we spend more time at the summit on the demos, we wanted to quickly show one of the many available tools and demonstrate how relatively simple it is to get started. So no deep technical skills required. And then lastly, we'll talk about what is the process for developing and using AI and ML-enabled solutions. So one last thing to keep in mind as I'm looking through this list of who's joined us is that we have a diverse group on this call. We have both technical and non-technical leads. We have nonprofits, private sector, academia, also many others from NetHope community. So for some, what we'll share on this call might be too much detail, while for others, they might want actually more detail on any of these 4 topics. And that's okay, because this is a journey, and you can review the recording and the slides that we'll post on the NetHope Solutions Center. You can also let us know what else you would like to learn more about, or what else you would like to share with the NetHope community. So with that, I'd like to invite Abra to kick us off with the first question, with the first topic. Abra, over to you.
Great. Thanks, Layla. And I hope everyone can hear me okay. Please let us know in the chat window if there are any issues with my audio. So let's click through to the next slide. So with this slide, the figure that we're showing here is the interlocking gears is really meant to demonstrate the interconnectedness of these 3 common terms that Layla mentioned that often get thrown around when we're talking about machine learning and artificial intelligence. So as you can see in the diagram, data is really the genesis of all machine learning and AI, at least in the context of what we're talking about today. Data is really the wheel that turns the other gears. And so when you have a lot of data that can be in any format, really, so text data, numeric data, audio, image, video, you can use machine learning to detect patterns that might exist in that data and then make predictions on future data based on those patterns. And so here are a few different types of machine learning: supervised, unsupervised, reinforcement, and we'll talk about that a little bit more in detail. But then when you think about how we often refer to AI, artificial intelligence, it's important to remember that AI is often relying explicitly on machine learning to make the predictions that are then used to automate something, to do something, or plan something. And we often refer to AI as smart automation. And so it hinges on machine learning and to detect patterns in the data, which is on the far left side of this gear. So we'll go through a lot of the different key capabilities that are listed here in later slides. So computer vision, NLP, et cetera. So now going into a little bit of terminology. And so just for clarity here, we are sharing a few more concrete definitions alongside a definition here for big data, which is distinct from the data that I was referring to in the previous slide. So in this space, quite often the lines between these 3 terms can be very blurry. And so it's useful to understand that while they do refer to unique approaches, there's often a broad kind of overlap in how the terms are used. So we shorthand machine learning to refer to data-driven predictions. We shorthand AI to often just refer to smart automation. And big data is kind of, I would say, an evolving term that is often used almost interchangeably to refer to machine learning or artificial intelligence or any kind of advanced analytics that require a large amount of data to be done. Okay, next slide. So here I'm going to begin to go through a couple of different types of learning, and then I'll hand it over to Cyril. So supervised learning is the first kind of machine learning that we'll talk through, and this is really, in my experience, the more common type of machine learning that in development we come across. So this is really where you, a human or a developer, has created a labeled training data set where the inputs and outputs are all defined. So for example, say you're working to build a model that predicts someone's likelihood of repaying a loan. With supervised machine learning, you would start with a historical data set that has all of the elements labeled. So each individual's income, their land ownership status, previous repayment history, and it would also have the output labeled, so whether or not they repaid a previous loan. So from that labeled data set, your learner would then work to detect what patterns exist with the strongest kind of correlations or indicators of repayment, and then it would build its model based off of that. So it's really relying on this labeled training data to make the predictions. Now, unsupervised learning is in common use, I would say, but it's not as widely used as supervised learning for development purposes that we've seen so far. So this, on the other hand, it starts without labels. You don't label the outputs in your data. Instead, you typically use unsupervised learning to work to learn if there are natural clusters or groups that exist in your data set. So for example, do potential borrowers share characteristics, or do they belong to distinct groups that might allow you to, for example, design and target different loan products to those particular groups? And so they're quite different in nature. And then Cyril is going to talk us through reinforcement learning, which is another type of machine learning that is far, far less common at present, but it's still worth knowing the distinction. So Cyril, I'll hand it over to you at this point.
Thank you, Abra. Reinforcement learning, while it's not absolutely new. It's much closer to research compared to supervised learning and unsupervised learning approaches. The really interesting part here is that it's a reward-based learning system, which means the AI agent that is trying to learn something is getting kind of rewards based on interaction that it takes with an environment. While this sounds relatively abstract, I can use the example of the game Go that recently has been able to be solved by Google DeepMind, where the problem is that the game itself has many more possible moves than the atoms in the universe. So it's a really large problem to solve, and it's not possible to just calculate the best possible move for a given state of the game system. So what you do is you take an agent, an AI agent, that interacts with the Go game a large number of times and slowly learns by spoon-feeding rewards into the AI agent what is a good move in a current situation and what may be not such a great move. And at the end of the training, where you're running, let's say, 1 million or 10 million or 20 million games of Go, the AI agent has learned to always find the optimal move for a given state of the system. Later. So when we are talking about these learning systems, at the core of these are, not in all cases, but in a lot of cases, a technology approach called deep learning. And you may have already heard that from the press and in the media overall, where we are defining deep learning as it's a part of a broader family of machine learning that is always based on artificial neural networks. So think about it, whenever somebody says deep learning, there is a neural net involved somewhere. This is the connection between deep learning and other machine learning methods. And these neural networks are, while they are inspired by natural or biological neural networks, they are not identical. They don't behave exactly the same way as animal or human brains operate. At a very kind of abstract level, you can think about them as they are trained to match inputs to specific outputs, while you have these kind of layers, computational layers in between the inputs and the outputs. And there are two terms that are important here. It's biases and weights. These are kind of computational parameters within the neural nets that are being adjusted. So you can actually train it by feeding it inputs, and then you're getting results on the output side. Let's say you have labeled image data that you're using as training data. You're running these training data through the inputs and then through the neural net, and then the weights and biases are being adjusted. So in the future, it can make predictions if it gets unlabeled data. And I will have an example later on where we are actually training a neural net using labeled image data.
Okay, so on to some of the key AI capabilities. So we just talked about a lot of machine learning examples, and now we're going to move on to the subset of AI capabilities that were mentioned in one of the first slides. And so this is just a broad variety of categories. There are others that we could go into more detail if there are questions. So the first thing that we'll note is NLP, which is something that you all may have heard in the literature or when people talk about AI. This is natural language processing. This is just using AI to analyze or to synthesize natural human language. So this is a new thing where we can, instead of using computer language essentially to communicate or to understand written text, you're actually able to parse apart natural human languages. So quite often this is used for English or Spanish or Arabic or some of the more dominant languages worldwide. There's often much less representation of languages that don't have such a strong digital written record. Another key AI capability is computer vision. And so this is using AI to process images or video in order to identify objects or interpret scenes or events. The image on the right of the screen that you see is an example of using computer vision. This is an image from a study that's being carried out in Rwanda by partners at MIT and Harvard to use computer vision to identify infection in post-cesarean surgical scars. And by training the learner on historical images of infected scars and non-infected scars, they're able to much more accurately predict early indicators of infection in post-cesarean surgical scars. Next slide. So other key AI capabilities that we mentioned, speech or audio recognition is a common one. This is where you can use AI to analyze audio files to recognize either specific sounds, like in the audio file, or speech patterns. And so quite often when you're using this for speech patterns, you're also relying on NLP. But for audio recognition, an example that the image on the right demonstrates is a group called Rainforest Connection that have used this technique to detect illegal deforestation. They have a network of sensors that then processes a lot of audio data, and using machine learning, they're able to parse out when there is a chainsaw sound present in the audio file. And with that, they can triangulate and then connect with rangers to send rangers out to identify where the logging is happening and intervene. A couple of other advanced analytics to mention here are just a couple of other key AI capabilities to mention. The first is advanced analytics, which is kind of a catch-all. This is just something where we're talking about the ability to process vast amounts of data and do more sophisticated analyses than might have been possible before. And then lastly, we won't go into much detail on this in this webinar, but it's worth mentioning the use of AI for content generation. And so this is quite common in the news these days, right? Generating content, whether that's images, video, deep fakes, but really generating realistic or likely realistic images or video or even text, right? Using an AI to generate that information. So next slide. So now we're going to go through a few practical examples just to root these different capabilities in the real-world demonstration of where we're seeing them at play in development and humanitarian applications. So the first example that we'll talk about is chatbots. And so these are a couple of apps that have been developed by other organizations where you're essentially using AI to tailor, to request information or to share information in a way that is responsive to the queries that are coming in. And so here you're potentially using NLP or speech recognition, and you're also using content generation, right? So you're getting information on the far left. You've got an app from the USAID Fall Armyworm Tech Prize. This is a winner that was using a chatbot to send information to smallholder farmers and to identify if there are specific recommendations to make based off of information about the season or the crops that the farmer is sharing. The chatbot on the right is something that I think you'll hear more about in an upcoming webinar. This is the Tessa chatbot that Plan International created, and this is something that I believe Bo or Haya is going to go into more detail and talk through, but it's essentially a chatbot that helps young women identify employment opportunities and prepare themselves for that. So the next example.
Just a reminder for everybody, so we'll be covering Tessa chatbot at the summit, so join us there. All right, over to the next slide.
Great, thanks, Leila. So the next example is a common use case that we've seen, and this is using AI and machine learning for personal targeting and screening. So the ability to be able to pick up subtle patterns of correlations in a data set can let you tailor predictions at a much finer scale than has previously been possible. And so this is where you're using potentially a broad swath of the capabilities that we've talked about to make more suitable predictions for at an individual level. And so the examples that are shown here on the slides, on the far right, there's an example called Farm Drive. And so this is using multiple sources of data, pulling together those sources of data and detecting patterns that might exist across all of those different sources of data to make predictions on how creditworthy an individual might be. And so this is using information about agronomic data, environmental data, financial data, and even satellite data for weather information and weather patterns to be able to pinpoint with greater resolution whether someone is likely to have the capability to repay a loan if given a loan. The example on the left here is from the Harambee Youth Employment Accelerator, and they've created a methodology for identifying patterns in a large data set that they've collected about systematically unemployed youth to make better predictions about a youth's suitability for a particular type of employment. And so what's novel here is the ability to look at a lot of different data sources that may not have technically been considered for previous estimates of the same thing. So whether someone is likely to be employable or whether someone is likely to be creditworthy historically has not relied on these more diverse data sets. It's really been more a matter of looking at past financial records, or past educational scores. And so using AI in these two contexts is opening up the types of data that we're considering as viable inputs for making the kinds of predictions that we're talking about. Okay, next slide. So another example to share in terms of key AI capabilities and what that looks like on the ground is using AI for humanitarian response. So this is an example, ADAR, that is artificial intelligence for digital response. And this is, in terms of disaster response, trying to get information processed and targeted at a rate much faster than has been possible with traditional methods. So here, this group at QCRI was using satellite imagery and other geographic information that would allow you to kind of pinpoint where the information was coming from to decide where resources should be prioritized in kind of first response to a disaster. And so this is, again, using multiple sources of data and trying to detect patterns in those multiple sources of data that allow decision makers to make more informed decisions about where to prioritize the delivery of humanitarian assistance and aid in real time or in very short order time. And here are the key technologies. Okay, we can go ahead and move forward to the last, I believe, category, which is vision and audio diagnostics. So here, this is using the key technologies, computer vision, sometimes speech or audio recognition, and sometimes NLP as well. This is where the apps that are being shown are analyzing images from cell phone cameras to diagnose disease in either humans or plants. And so the app on the left side is using using images from a smartphone of an individual plant leaf to diagnose pests or specific diseases. Here, this is an app called Plantix. And so that's able to identify patterns. Again, this has been trained on historical data of pests that are present in different crops, being able to identify those pests based on the patterns that have been fed into it that have been detected by the learners, and then predicting recommendations that a farmer should then follow based on where the plant's pest or disease falls on a spectrum of, whether it's early in the life cycle of the pest or the disease, and if so, how the farmer should intervene. The app on the right is an app called Peak. This is something that's being used for cataract screening. And so with a small, relatively inexpensive add-on to the smartphone, you can do this imaging of the retina and identify if there are cataracts present or not. Again, this is just based off of machine learning to identify the patterns that are more likely to be predictors of cataracts so that you can have an earlier intervention if there is an early indication of cataracts. And so these are the same kind of diagnostic tools are used across multiple fields, so that can be agriculture or health and others, right? It's not just limited to those. But these are some of the most common applications that we've seen across the development and humanitarian space. And I believe at this point, I'll hand it back over to Cyril to walk through a little bit of a hands-on demo of what we're talking about when we talk about image classification and video and audio diagnostics.
Thank you so much, Obra. So we are now spending a little bit of time to show you really a practical example, but it's a really simple example, but it's practical. I'm using a tool that is off the shelf available at customvision.ai. You can build classifiers, image classifiers by yourself. In the next few minutes, we are building an image classifier around apples. So let me go and switch over to the service itself. And here, this is how the interface looks like once you have logged into the service. And as you can see here, I think somebody already did a little bit of work, but let's say we are starting a new project. And I'm being asked create a name, so I'm using demo. I'm using a description. It's an apple classifier, which basically allows us to identify whether it's a specific type of apple or not. I'm selecting classification, and then I'm selecting the general domain of food. I'm creating my project, and as we talked a little bit about training data and why this is important, we're now using images for training, and I've prepared two sets of images that I downloaded from Bing So I basically went to Bing and said, I'm looking for green apples and I'm looking for red apples, and I downloaded the results. So let me add the images here for my classifier. It will take a second to upload. And I'm tagging these. These are my red apples, so I call them red. This is important because that's the image label. When we think about supervised learning systems, it's all about labeled image data. So in this case, these are my images, and they are labeled now with the tag red. I'm uploading my images for red to the service, and then you can see here they have arrived. And then I'm going back to give another data set with a different label, and these are my green images, or my green apple images, which I call green, and then I'm uploading these files. So I have two training data sets, one with the label red and one with the label green, and I can now start here in the upper right. I can start training, and I select fast training. This will take a few minutes only, but in the because we are running, I think, short on time, I will switch over to the pre-trained model. You should expect this to be like 3 or 4 minutes, given the very simple classifier that we have built. So if I go back to my initial project and I'm using the classifier that I'd already trained before, you now can test how good is your classifier. If I now take an image that the system has never seen before and does not have a label, right? This is really important. You're now testing your system, your trained system, with something it has not seen before in the training data, and it's unlabeled. So I'm clicking on a quick test, and I'm browsing. I take a local file from my computer, and it's actually an apple, a photo of an apple that I took in the kitchen yesterday. This is here my apple, and see the prediction here in the lower right. It says it's 99.9% a red apple because it matches what it has learned from the data set. So let's do a couple of other tests quickly and see if I'm taking different apple images that maybe are a little bit more kind of in the gray zone between red and green. So let me take something that maybe looks more like a yellow apple. And we are, again, seeing the predictions from the system, and it classifies this as red. Even though the apple, you would qualify that probably more like a yellow apple than a red apple as a human. And the interesting piece here is the system hasn't seen yellow apples before. So it looks for features or identifiers in what it has learned, and it recognizes some of them here in this. So you see that it has a little bit shade of red. And so that's the reason why it says, oh, it's a red apple, because it has no other ability to make any other decisions. And if I continue trying doing this with maybe something else, I have another apple here that is also more yellow, but a little bit more greenish. And in that moment, the system will also say, oh, I recognize features that I've learned that are green, and so it will classify that as a green apple. And lastly, what happens if I put something in there that it hasn't seen at all yet, and it doesn't even need to be an apple? So I take a picture of a banana, and I run that through the system. And there it's getting really difficult because there are some kind of brownish, reddish tones in here that it may think it's a red apple, and but there's quite a bit of green in that picture as well, so it tells you that it's a green apple. So this is really important when you're using image classifiers, that you have data sets that are matching what you're actually trying to test for. Otherwise, the system will give you somewhat random results back based on what it thinks it has learned and what kind of feature it has seen in the image data that you used for training. So let's hand back over to the presentation. Okay. And what we have seen now, and I want you to kind of key takeaways when you think about AI and machine learning. Please keep in mind that the systems can only be as good as the data that you're feeding them. So there's this saying, garbage in, garbage out. If you're feeding the system data that has problems, that is problematic, that is not complete, that is not matching what you're aiming for, then you will not get the results that you want. There is no magic here. This is all math. You're matching labeled training data against later on predictive data, and you're seeing the results. So keep that in mind, please. In the same context, large data sets are required for high accuracy. Large is a relative term, but please don't underestimate the amount of data that you need to get a model trained that is really accurate. And I know that having access to labeled data it's not trivial. So especially in the development context, if you are looking for an application of AI, keep in mind that where do you get the data from if you don't have it? How do you label the data? How do you keep the data fresh? How do you update the data? Because these are all inputs that have such a dramatic impact on your results. Feature extraction, and we talked a little bit about that, and Aubra mentioned it as well. The AI system has to learn what is actually it sees, because you can see in the demo that I just showed you, we never told the system what is green and what is red. We just said, here's a data set and here's another data set. So it learns by itself to identify what makes it green and what makes it red, but it's not something that we as humans understand. So this kind of feature extraction, while that is incredibly powerful and we don't have to do the work, it is also added some complexity because we may not understand how the system works and how it makes decisions. So explainability of these AI systems is still something somewhat unresolved because it makes its own decisions how to identify these features, and that also then means it makes its own decision what it's going to see and predict. There has been some progress being made in research, mostly around kind of how to debug your models, but it's not something that the general human audience can easily understand how the systems are making their decisions. And lastly, please keep also in mind that these machine learning approaches are not suitable for every problem. They are mostly suitable for problems where it's relatively straightforward to see, I know what the correct answer is, and I can teach the system to give me that correct answer back. If your problem requires some sort of common sense or is ambiguous, these machine learning approaches are really losing their power. There may be some research in the future where they are getting better to have more nuanced capabilities, but in the current state of the systems, they are pretty much black and white. I think I'm handing over back to Aubra.
Okay, so in the interest of time, let's skip this slide. You'll all have access to it in the deck once it's sent out. So let's go to the next slide. So really, just to reiterate what Cyril just said, I think it's important to spend a couple of moments on this slide in identifying that developing and using AI and machine learning is a full process, and that whole process requires a lot of human judgment and judgment calls to be made across all steps. And so here we've broken down the steps into three main categories, the first being focused on data and reviewing data, getting to the point where you've labeled your data if you're using supervised machine learning or done some exploratory data analysis, et cetera. The second panel really is on building the model. And so sometimes that can be a pretty straightforward thing, but most times it's not what Cyril just showed. It's a much more involved process. And so this is where you can ensure that your modeling problem is well defined and that you're actually aligning with what you're setting out to do. This is where you select what is the outcome variable, for example, that you care about, right? So if you're working on creditworthiness, do you want to predict the likelihood of repayment or the timeliness of repayment or the likelihood of default, for example? So all of those different things need to be defined as you develop your model, and there may be subtle differences that come up or that emerge based on those kinds of decisions. So here in this building the model phase, there's also this critical feature that Cyril mentioned of choosing what features you'll use in your model. And so while this may seem straightforward, this is often one of the more important decisions that a developer will make. So if you're predicting, again, creditworthiness over certain time periods, for example, you can choose that one of the features or the elements that you feed into your model is time, and whether that time is measured in days or months or whether that's time as measured in harvesting seasons can make a really big difference. If you pick up patterns of repayment that center around a harvesting season, that's much more likely to be a strong model. And so the way that you think about defining your problem, defining the features that you're using, engineering those features really has a lot to do with the success of the model that you're generating. And the last step often gets skipped over, but it's a really critical step as well, and that's integration into practice. So this is really about considering where the model will go, who will use it, how you'll ensure that those who are going to be affected by the model are going to have an opportunity to feed back into the model. And the last thing I'd note on this slide is just that these little circles in the bottom of revisit is just to emphasize this is all an iterative process. It's never just a straightforward linear start and finish kind of progression. These all need to be revisited as you go along and learn more about your data and learn more about the model parameters that you're arriving at. So let's skip to the next slide in the interest of time. And here, we're just going to step through those three phases in a little bit more detail to consider what this looks like in practice. So we have a concrete example here. We're working to identify the presence of malaria in a blood smear image. And for this, we're going to use supervised learning and computer vision. So next slide. So for this example, you'll want to start by determining a number of things about your data and about the situation. So here, you're just going to say, what are the number of red blood cells? What are the number of white blood cells? Where, is there presence of the malaria parasite in this particular sample? And trying to identify what is captured in your data and what's not captured. So slide 25, the next slide. Thanks. So a closer look at data review. So here, this is really just spending a little bit more time thinking about what we mean by data review. So this is just, when we're talking about supervised learning, how are we going to label our image data? And so here we would imagine that we would go through each cell and identify whether there's a parasite present or not a parasite present on that image. We would also want to clean the data, right, and just make sure that what we're dealing with is actually good samples that are going to be the right kinds of things to train the model without introducing all sorts of noise. So next slide. So here, features, as I mentioned, is a really critical element or a really critical step in defining a model and making the model work. For this example, for computer vision, these are generally predetermined. So these are things like objects, shapes, edges and corners, colors, et cetera. But for other applications or other data types, they're far more varied. And so the machine learning developer is going to have a lot more opportunities to input what those features look like. Next slide. So here is just diving in on the model building step from the perspective of evaluating your model. And this is also a really important critical piece of model building. So this is really, how do you plan to evaluate the success of your model, right? Is it just about how accurate your model is in predictions? Or is it about the likelihood of getting a false positive? So say we misdiagnose a cell as having a parasite present versus in reality it did not have a parasite present. Those are the kinds of decisions that you need to make when you set out how you're going to be deciding whether your model is performing the way that you want it to perform. I think that this is sort of going to bleed into the next slide in terms of the integration into practice, because the way that it's important to think about your decisions as you are a developer building these models is when you make these judgment calls about how you're going to evaluate the success of your model, it's really important to think about how that's going to be integrated into practice. If you get something wrong, say you have many false positives or many false negatives, what are the human consequences of that? And so how is that going to translate into, will people ultimately end up being misdiagnosed and mistreated? And so thinking about if I get this wrong with the false negative, that I've misdiagnosed someone as not having malaria, is there a high cost of that person potentially missing malaria infections in a person versus the cost of having false positives? Also, what are the consequences of changing the procedures that are in place for diagnosing malaria? Is using machine learning going to incur new costs that can be sustained or can be supported for a long time or for just the near future? Also thinking about things like how accurate does the model need to be to actually improve where we are today? So what is the status quo and what are we shooting for? And then the other column on the right here, establishing proximity to final decisions. It's really about thinking about, is there going to be a human in the loop when it comes to decision making? Will there be an individual that can intervene if the model is wrong or is slightly off target? Or is it really consequential, the way that the prediction is being made? And that should have impact on how the model is designed and how you evaluate the success of the model. And I know we're running short on time, so at that, I'll hand it over to Layla to wrap us up and head us over to Q&A.
Thank you, Abra. Thank you, Cyril. We certainly covered 4 questions that each could actually take up a whole workshop to go into detail on. Thank you so much. And clearly, this has inspired many questions. So I'm going to skip through this slide. You'll have the opportunity to see, again, all the sessions that we have planned for the next couple of months. And then most importantly, let us know what else you would like to learn about in terms of AI, or what you might want to share in terms of the practical implementations and lessons learned. Contact information is posted here. And what I'll do right now is go, together with Frederick, go through a set of questions and try to group them as much as possible. So the first set of questions is around data, and I'll share a few questions that have come up and then let you, Abra and Cyril, comment on any of these questions. In the context of low data availability due to access and lack of infrastructure, so for example, Northern and South Sudan, what may be appropriate applications of AI here, if any? Are there small AI options, so quote, small AI options where models can be developed on limited data sets? Similarly, are there any examples of machine learning for forecasting consumption in the field with lower quality of data? So again, not much data, lower quality data. And a third question, I may have some data internally. It's really spread all over the place, and I suspect there are some external data sources that can be helpful. Can you talk about how I get these sources organized before I get started? So we're talking about small quantities of data, lower quality data, and data spread across the different sources, both internal and external. So Abra, should we start with you first?
Sure, and I'll try and blaze through them. I think there's so much to be said on all of these questions that we will not be able to answer all of it, but I do think it's the right place to start. I've heard many people say that machine learning is 90% data janitor behaviors or whatever, doing the cleaning, the heavy lift of getting data sets cleaned, getting them well organized, getting things in place so that your model development actually is productive. And I think that that's not a crazy estimate of the split of 90% of the time is focused on the data. I do think that this is one of the more pressing concerns for us as a development and humanitarian community as we try to turn to this technology, is that we are often limited by low data availability, low quality data when we do have data, and then also just data all over the place that's not easily mergeable or organizable. And so I think one of the main things that I would say is, yes, it is possible to use AI with those constraints, but I think we need to be very, very careful about turning to AI with those conditions and spend a lot of time on, for example, the exploratory data analysis phase, where you're trying to identify if there are any repercussions in having huge data gaps or having specific quirks of your data. And then also trying to identify if there are specific biases that we're introducing with that poor quality data. And so that's something that we'll talk about more at the summit. But I do think that there are ways to mitigate these issues. It's just a matter of really being, again, eyes wide open and aware of the concerns that that introduces in something that is so heavily dependent on vast amounts of data and high quality data. I'll hand it over to Cyril at that point, even though I know there's a lot more to be said there.
Yeah, Cyril, anything else? Yep.
Oh, I would only say that in some cases it makes sense to start regardless, just to get your kind of feet wet, and then see if you can also kind of reduce the model that you're creating, maybe select less features based on the data overall that you have, just to see if you can learn something from it. But then that gives you also the justification to go after more data to make your model better. But I think it's always good to start somewhere, but keeping this in mind that the quality of your model may be impacted by the low amount of data that you have.
Thank you both. Clearly, we can have another session just on data. we do actually have a webinar that we hosted just a couple of months ago on how to get your data ready for AI, and we'll share the link on the landing page for this webinar. So moving to the next question, has there been any feedback on the field applications of AI, specifically successes, failures, challenges? I think one thing that I'll note, and Abra would definitely want to hear from you since you worked on specifically on the guide around practical implementations of AI in the development sector, is that what we're seeing is many pilots and many proofs of concept with no significant impact or scaling yet. But what we're also hearing from the NetHope community is desire to learn from each other, specifically what's working, what's not working, and how to begin scaling some of the work. So, Abra, over to you.
Yeah, I think that's a really critical question to be asking at this point, because we need to not just be piloting to the point of pilotitis. We need to be learning and building off of what others have learned through their pilots, and that's why I think we're at USAID pushing for this stronger focus on how we can share learnings across implementation of AI and development, because they are becoming more commonplace, but it's hard to really glean learnings from AI exploration when it's under lock and key, or when it's just in someone's hard drive somewhere, or someone's head somewhere that isn't connected to another person that's wanting to explore the same type of AI. And so I think the more we can push for actual evaluations of how much AI has or has not improved processes or has improved efficiencies, that's the critical point I think that we find ourselves at now, because we know that there are demonstrations of use cases where AI can be powerful. We haven't yet seen, as Layla is saying, AI at scale, or AI in a way that's going to be transferable across multiple contexts without introducing harm. And I think we have a responsibility to do that due diligence of understanding where there are real value adds of AI and where there's not. The one area where we've gotten a little bit more deep in our understanding has been when we've been able to embed with a specific organization that's using AI and learning from their own use of AI. And there's a lot of rich learnings that have come from that process. And I'm sure a lot of other people who have done similar things would say that that process has been rewarding and led to generalizable insights. But we haven't yet seen kind of a dedicated effort to target evaluation of implementations across the development and humanitarian space. I think there needs to be a lot more of that.
And just one thing to mention, one of the frameworks that I mentioned earlier at the beginning of the presentation was actually created to help the practitioners as well as their partners think through all the stages, which includes asking some of these questions around data, around the infrastructure and the resources, around scalability, extensibility of the solutions. So take a look at also that framework as you begin exploring AI specifically for your problem statements. And we'll actually have a hands-on session at the summit that's focused on that specifically. So, Frederick, there's a whole set of questions, I think, for Cyril, if you want to kick us off.
People are very, very intrigued with your demonstration, Cyril. So here's the comment and question. It's interesting to see tools like what Cyril showed. Are there other non-technical tools that can help me get started with AI or machine learning? I would love to see an application in health data. Can you comment on that?
Yeah, I think in principle, I would say all the large tech companies, Microsoft, Amazon, Google, IBM, are trying to make AI and machine learning more accessible. That also means they are providing, and we are part of that as well, providing more kind of visual tools where to some degree you don't have to be a programmer or kind of being interested in data science. Fundamentally, the closer you're getting to really integrating these models into your production, you have to become comfortable with data science to some degree at least. So the overall idea is to democratize AI and make it accessible to a larger audience. So I don't want to call out specific tools, but Microsoft has a bunch of offerings. As I said, Google, IBM, and others have offerings as well. I would just look into them and see. Open source, by the way, is a great provider of tools as well, where you find something that fits your needs.
So, Cyril, just to add two things here, the second link that we shared with you includes the initial version of the repository of tools and services and training resources, and we've invited all big tech companies, AI platform developers to contribute to that. And then second, at the summit, we plan to spend a bit more time on the kind of demos of these off-the-shelf tools and services. Frederick, over to you for the next question.
Yeah, it's super interesting to see how we put these types of very complex areas of technology itself comes to the rescue, where we can, humanize things a little bit. It's very, very interesting. The next question is a little more complex. Maybe you can make it super simple. In your Go example with a game, how do you know what's a good move or a bad move? Is this a human that makes that distinction and provides positive reinforcement? I'm not sure if I understand.
That's a great question. So it's correct. A human has to define what we call the reward function. So the human understands how the game operates and says, all right, I may only reward you for winning the game. That may be a reward, very simple. Maybe too complex to get to because the AI has to learn a lot of things in between before winning the game. Another approach could be that in Go, how the game scores, there is already something that while you're playing the game, you can say, well, this is a better move. So if I can catch some other stones, maybe I already give you a little bit of a reward. And then I'm giving you the full reward if you also win the game. So you can think about it in a way where in applications where you can already kind of in between the stages identify whether something was a good or a bad move, you can give, we call that sparse rewards. Or you basically, if you can't, then you just wait until the end and say, okay, I'm only rewarding you for the final result. And that may increase your training times quite a bit.
Great. Thank you, Cyril. And obviously, if you have any more questions about reinforcement learning or deep learning, do connect with Cyril. So just the last set of questions related to NLP and chatbots, specifically, Abra, what do you see chatbots can be better than humans? And also for world languages, I understand there are resources to develop NLP capabilities, the natural language processing capabilities. How can this be done for local languages?
Okay, so two great questions. The first one about chatbots, I would say, I don't see many things that chatbots can do better than humans, but I do see chatbots often filling a workforce gap when that exists. So, for example, if you don't have enough doctors in a specific country, sometimes chatbots can provide a very low level of back and forth to identify if someone needs to come in to see a doctor before they go to the clinic. And so that kind of conversational interface that's slightly more tailored to the person that's asking the questions can reduce a certain amount of workforce need that would have otherwise been there. I think there's a lot of concerns that come around from that that we can explore further in the bias-focused sections at the summit, but I do think that that's one area where chatbots fill a workforce gap. The second thing is on areas where there's like a stigma to going and seeking help in person, that's somewhere that chatbots seem to be also providing a value add. And so, for example, in terms of providing mental health services, if it's stigmatized to go and seek out mental health support, sometimes a chatbot can create a more a less stigmatized way of seeking help. Quickly on the NLP question, because I know we're running out of time. So this is an area where the biggest issue, there are two big issues. One is attention on specific markets and the size of the market. And so for local languages that may be less represented in current NLP tools, quite often the motivation for that is that there's not as strong of a market, which I think is we're trying to change that because I think there are a lot of questions around those assumptions. The other element is around the lack of availability of digital text in that specific language. So sometimes you have a stronger digital record of text for the more dominant languages, and that's ultimately what a lot of these models' performance comes back to, is the size of the corpus or the size of the data that you're using to train these models. And so as we work to broaden the scope of what NLP can, which languages NLP can support, I think that's one of the critical things that we need to address. And there's a lot of really exciting work that's being done on this at various universities across the globe. And we'd be happy to share resources on some of that really exciting research after the webinar.
Great, thank you, Aubrey. Well, with that, we're at the top of the hour, so just a reminder, this is one of the many sessions that we plan to be hosting. If you have any feedback on what else you'd like to explore, let us know. A huge thanks to Aubrey and her team, and also to Cyril for the collaboration on this webinar and also past workshops. On this slide, you'll also see some of the links to the frameworks and tools and services that both USAID and Microsoft have contributed to. So thank you for joining us this morning or this afternoon. Over to you, Frederick, about the poll.
Well, thank you much, Leila. And thanks for putting on this series of very, very informative sessions. Taking on complex and emerging technologies like this is going to be game changers for the sector. And we're glad you're taking it and giving us in bite sizes. And looking forward to your sessions at the summit and deeper conversations going forward. So thanks to Leila and Aubrey and Cyril, and also to the audience for fantastic questions and great interaction. Looking forward to seeing more interaction and more learning on this going forward. So keep yourself glued to the NetHope Solutions Center, where we're going to announce all of this, and we'll send invitations out. Last but not least, please help us improve the webinar series by answering the simple webinar satisfaction poll. And I wish everybody a great rest of your day. We'll be back in touch soon. Take care, everyone. Bye-bye.